Okay, so this is a metal rod, and what I am doing is I am passing a voltage V, and the current is flowing here is I. All right. So metal has its own resistance. Suppose I call it R. So this then what does Ohm's law say to us? V equals to V is directly proportional to I, and R is your constant of proportionality, which is called the resistance. So V equals to IR. All right, this is the Ohm's law. So analytically, this is the equation. Like if you consider versus I plot, then analytically it will be a straight line, right? Passing through origin. Yes. But I want you to go in a formal way. What is the formal way? You are conducting the experiment to find the resistance value. Okay, what you have is only the resistance value you don't know. Am I right? Resistance, how much current is passing, but your job is to find the resistance, because a resistance of any metal you don't know. You just pick a metal from anywhere, maybe bracelet, and you try to find what is the resistance of this. So what you do for different, any voltage you give to your metal, similarly the current will change, right? Yes. So you give different voltages, you will. Yes. So in that way, for different values of voltage V, you will have different kinds of data points. A lot of different data points. So these are the data points you gathered experiment by using your amp meter and all these things. You have those amp meters and all in physics lab where you can find the current. Okay. So something like this, but you never see a linear line. Yeah. Yes. So you are partially nearly correct. Any other ideas? Why we are, see V equals to IR, right? So if we plot V versus line passing through origin, but instead we will be still behaving linearly. Still behaving linearly. Like here you can see that it is positively correlated with I. V is positively correlated with I. As V increases, I increases. But you will not see a straight line. You will see a smudge of points. Why? A very debatable concept, which mathematicians or researchers, when they were framing about theory of regression, faced a lot of difficulties. Okay, when they found a law, they found V equals to IR, but when they saw the plot, they saw the theory is not relying on the practical. How they will do? Okay. So now you can see these are the experimental data points. Experimental data points. That is Vi and II. All right. So say I equals to 1 to n. N number of data points you have. All right. Now, our idea is like suppose for a given voltage, say V star, we want to find what is the value of current I star. Okay, this is where regression comes into picture. Answer the question. To answer that question, we have to say the experimental data set resembles something like this for each of your data. That is II equals to Vi by R plus some epsilon I. What is this epsilon I? You see, it is a linear quantity, but there is some addition of epsilon. So this is random noise. Okay. So this is a random noise. In real world situation, or error creeping in your experiments. So therefore, you are never seeing a straight line rather than a smudge of points. Okay. So straight we know we know that the noise is there in your experiment, but we can never evaluate it in our computer systems. Okay, because we don't know what kind of noise it is. Real world noise you can never accumulate. You always model the noise. Therefore, the noises, I don't know if you are aware of it, like Gaussian white noise, okay, random noise, noise following normal distribution with zero mean. So all these are like modeled by us, but our aim is to mimic that kind of noise. Okay, so therefore, experimentally you can never evaluate this noise. This epsilon I is a random noise. You can't evaluate, but we have to take that into account that it is there. We know it is there, but we can't evaluate it. Okay, so that's the basic idea for why you are seeing. So you following the trend, but it doesn't pass through all of the points. Why it never passes through all of the points? Okay, so these are the reasons. Always face errors. You will always face noise in your any data. So therefore, be there which will not be aligning in your predicted regression line. Okay. So noise is due to many sources, as Alpin like pointed out. It is due to a temperature difference, maybe. Okay, so maybe due to that the noise is there. I have written in my notes why you can't evaluate the noise, so that you should read. Okay, I have number of equations and number of unknowns. Okay. So you should read it. Okay. The whole idea is in your set of equations, if you have a random noise epsilon I, you have one more unknown, okay, to solve. Also came to know about that regression is a part of machine learning that is comes from the data fed to the algorithm. Okay, data is fed to us, and regression is like learning from the data, supervised learning. So regression is a technique which is used to develop models, of course, or parameters of a model from data. Okay, and those data are usually experimental. Regression is to estimate the value of dependent variable for a certain value of independent variable. That means here, as I said, for a given value of V star, your job is capital I star. Okay, so that's the job of the regression. So here I will remind you again for your second problem. Oh, sorry, first problem since first class. What is the difference between interpolation and regression? That is an important question. And another important question is the one which I told you to read from the notes. Okay, whichever I am saying important, those are important. Okay, so those will be maybe can be phrased like philosophical questions. So you faced many philosophical questions in data analytics and SEM, right? So given a particular real life situation, how you will do this? So similar kind of things you can expect from these parts. Okay. All right. Like maybe I will denote notation. Say the data points I'm denoting by a set T, like a training data set. T like a training data set. And those are like just a collection of points. Nothing. These are running from I equals to 1 to n. So this is your training data set T. Okay. So what is this T? It's the training data set. Maybe if I did not mention, I would have just said only about this. I would not say about T. Okay. So this is where we are bridging the machine learning and regression part. Okay. So what we will do, given this set of star independent variable, what's the value of a dependent variable? Okay. Star. For x star, what is the correct value of y star? That's the aim of regression. Yes. If you want to do this, we have to fit it, right? We have to find a function. Okay, that's what regression will be, as we will be coming to know. It's denoted by y hat. Just follow the tricky part in regression. Follow the notation, what I'm saying. So y hat, if you are solving at x star, that is like y star. Yes. So y hat is like the curve, maybe the curve which you are predicting. And star, you will just plug in x star. It will give you the value of that. Got it. So in terms of machine learning jargon, this is known as a training data set. T is known as a training data set. XI is known as a maybe XI is known as regression. All right. YI regressor, or also there is another name feature. So whenever in machine learning coming across regression and it is telling it is like the same name as regression, it is the same name as the independent variable. Okay. YI, what is YI? YI is your response, also known as the label. So you will never face in any numerical. So so sometimes what you can do, you can, if you have a data set, we know from final version will be make it ready for visualization. We saw that you always need to visualize your data. So after you visualize your data, then you can actually get an intuition of what is the distribution. Is it linear? Is your data linear? Like in this example, we saw that it is fashion. So what you can do a linear regression. You can not apply non-linear regression model to this, right? Why? Because intuitively you know that it is following a linear. So sometimes visualizing the data is in some or applying a regression model. So therefore, like if say if your data set, if your training data set, if your data set behaves linearly, so what you will do, you can opt for linear regression models. Yes, that's the idea. If your data is behaving non-linearly, that we will cover, and you will see that the whole basic idea is the linear. Yeah, say exponential, varying exponentially set of data, which is varying exponentially, and you are asked like to fit using regression. Then I will tell you, you will see that we into linear regression problem. Okay, so even so you know which is powerful. Actually, linear regression is powerful, even if it doesn't appear powerful at first sight. So that we will solve a lot of different examples, both by Python and also by hand. Okay. So how it will look like, say your data will be like y equals to theta naught plus theta 1x, and then we are respecting the error to be there. Note that this error epsilon is in So again, so you can get an intuition why I have written like this. So first part is a linear regression term, and we are adding epsilon. The important things, and since this noise, this noise, yes, since this noise is added, okay, this is a random noise and should have a zero mean. Why zero mean? Yes, that is more sophisticated. More sophisticated. Okay. So yeah, discussion of this epsilon is more oriented towards a bit of deep oriented statistics. So I like more towards MSTAT courses where you will deal with a lot of different noises, Gaussian noise, like white noise, brown noise, red noise. So there are different kinds of noise. Okay. And people like researchers, they use their own kind of noise. Suppose your data is having a long tail. It is having a long tail. So then what you should use? You should use Levy noise. Levy noise is usually like, how many of you have heard of Levy noise? Levy noise. Levy. L-E. Levy. So that's like if your data set, if in your data set you are seeing long tail, then you can think, that I want to model this kind of system. Then in order to mimic it, you have to find, then Levy noise comes into picture because Levy noise follows this long tailed distribution. Okay. So this is like Levy distribution of this. Okay. Yes. So the starting of the regression, which I am telling you, got complicated because I started adding noise to it. Okay. But while solving problems, we will not add any kind of noise. But in programming, we will. But I think like adding noise is more clear. Any of your regression class, in data analytics class also, I never added any noise and just gave you data set. Therefore, for this one, at least I thought like you should know about, this noise terms that is actually there. Okay, so first we will be like covering least square regression. Okay. How it is again, say y equals to y hat plus e. Okay. Y hat is your actual regression and e is your error. Okay. That will always add. Okay. Y hat, again we saw y hat will behave like W naught plus W1x. Okay. Now you should see, yeah, you should ask question. Previously you wrote theta naught plus theta 1x. Now you are writing W naught plus W1x. The real world, like this is a natural model. This is a natural model. Like your model. Find W naught W1. Noises you can't evaluate. I already told you. Okay. So again, we have a discrete like. So you should ask me what is y hat. What is y hat? See, given a set of data points, our job is to estimate it, right? Our y hat, that it will find the best fit for. So now maybe the notations are a bit confusing. Hold on to it. It will be clear. So you see now that for your training data set T, so everything, I don't have to mention xi, yi again and again. Okay. X. That means I am already saying to you that we are already data set T. Okay, it is given. Every time I don't have to say it. Okay. This is given to us. Our job is to find what is y cap of x star. Yes, that is like the predicted value. Everyone understood this? Yes. You x star is being given. Y hat is the estimation function which will give us the best fit. And I am feeding x star to that estimation function. And what will be the output? I will get the dependent variable as the output. Okay. And that is y hat of x star. Okay. So what is our regression model here? This is our regression model. Our job, see, now our job is what? Data points, we want to find estimation function. That is y hat. That is y hat, w0 plus w1x. X is known to us as a set of data points. What is unknown? W0 and w1. If that is our next step, given a set of data points which are linearly related, okay, and you are trying to fit a linear estimation function, that is y hat, which I have written as w0 plus w1x. Our next job, in order to fit, is to find what is the value of w0 and w1. You understood what is our job? How many of you repeat? Repeat. 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 Okay. Okay. I will come back to this example. Set of, we have a data set of like data, right, which are linearly correlated. Yes. And you know that V equals to IR. You know V equals to IR. But in real world scenario, we don't know what noise it is. Since Albin told it might be temperature, he might tell us like it might be due to like humidity or maybe some water, some corrosion of a metal. Different. So how many things you will consider? It is infinite parameter mode. So therefore you can never evaluate real world noise. You can never evaluate. You can consider the effect of real world noise, but you can never evaluate the real world noise. Okay? We humans, like we can model the noise. There is no single formula for noise. Therefore, different scientists are coming with their own formula and own type of noise. Gaussian white noise by Gauss, Levy white noise by Levy, okay, red noise, brown noise, and all those. Particularly suited for different applications. Our idea is, suppose these are being given, this data set is given to us. So you will have only numbers. V and I numbers you will only have in your data set. Okay. So you want to fit a best to this data set. That means something like this. Line this curve, straight line, your job is to find. W0 plus W1x. Yes. Does it pass through origin? No. X equal to 0 if you put. So I'm just saying an example. Your job is to predict this straight line. How you will plot the straight line? If you don't have W0 and W1. For that, you need to know W0 and W1. Do you need to know X? That is given to you. X is the independent variable. That data set you already. So our main aim is to find W0, W1. After finding W0 and W1, you can just plot your curve or regression. Yes. So our job is to find W0 and W. Set of data points where your error will be minimized. What is that error? These are your points. Data points. So this is your data point, and you see difference here. You see there is difference. There is some difference between this data point and the regression line. These all considered into effect, all will be summed up together. That error. So that regression line that regression line, not just any regression. Then I can say, yes, this is another regression line. This is another. We found that the black color ones fits the data best. That means it is one of the curve which gives the minimum error. Understood? Okay. Understood. Clear is. Okay, so you know that our job is now to find like what is W0 and W1. For that, I gave you a small hint of pinch of salt. Like I told you that we have to minimize that error. If we want to minimize the error, then we have to write the error analytically. Yes. I can directly write the formula here, but online, just two lines formula, and you have already seen it. You have already seen that formula in last 1 or 2 classes of data analytics. Okay, but how it came, you don't know. Again, error is denoted by E, capital E, and I know that it will depend on W0 and W1. Is it clear? Error depends on W0 and W1. Yes, see, if you vary W0 and W1, if you vary I hat is W0 plus W1x. W0 and W1, you will get different slopes. So the lines will be differently oriented. So therefore, you will get different straight lines. Okay. So therefore, the error will depend on W0 and W. So there is a reason I am writing E as a function of W0 and W. Who is not able to understand? Why? I did actually. Okay. So we were planning to introduce the linear fit to our problems, right? To our data set. How it is? We will just use y equals to W0 plus W1x. And our job is to find the coefficient W0 and W1. Okay. But we have to find, like, our job is to find a formula for them and W1. And we will do general case so that any data set is being applied to any data set. Okay. So we don't need any line with W0 and W1. As we saw, we want the fit which gives us meaning. What do I mean? Suppose I select a line like this. Why this line cannot be taken as a best fit? You should ask yourself why. Because these are your error between each of the data points. They are so much large. Yes, but if you take the black ones, you see yes, yes. So therefore, if you are given blue, why? Because the error is less. Error between the line and the given data points, the distance between them. That is the error, right? You got it. This is the actual value, the black point here, and this is the predicted one. So this is the error. Yes, and how you will do it? You will just take the distance between them and sum those distance up. So you're summing the errors. Then you can take the magnitude and find where it is minimum. Okay. Now we will do in a mathematical way, find the distance and we'll put a minimization condition when it will be minimized. You know, from differentiation, if you want to find minimum or maximum of function, you will set and then take the second derivative in order to for it to be a minima or a maxima. Yes, the same thing we will do here, but rather than derivative d by dx, you will see dou. Why you will see partial derivative? Because it is a function of more than one variable. Error is a function of W0 and W1. Is it with respect to W0 or W1? So therefore, it's okay. So suppose these are our like data points x1, y1, x2, y2. These are experimental set of data points. Yes. Our job is to fit a straight line. That is y cap equals to W0 plus W1x. Right? And we want to minimize the error. How we will minimize the error? So this is how I am defining the error with respect to like the W0 W1 means error is depending on W0 and W1 coefficients. How I will write it? Visualize this, why I am doing this. Can you tell the next one? W0 and W1 will be the same. Till the nth point. Square of all those things. And we are taking the average. N points. So we are summing the error up and taking average error. Dividing by n. Why we are doing this at the first place? Why we wrote such a big? Our aim now is to minimize E can be minimized under two conditions. What are those two conditions? First of all, before going to like grad E equals to 0. You know grad E. Grad E, right? But we don't need to worry. We will write in terms of partial derivatives. All right. So if writing in partial derivatives, how it will be? Minimization condition, I will write two conditions. One is dou E by dou W0 equals to 0. Right? It's the simple, you can correlate. If you are asked maximum and minimum of a function, you set the here you are setting partial derivative to 0. Yes. Now the second condition is by doing this, you can get minima or maxima. Actually minima, right? So therefore, you need a second condition, inequality. Yes. So that is our second inequality, which is not that trivial. It is very trivial in case of like the ordinary derivative, but it is not that trivial for the derivative. Don't need to remember this, but just want to see how this process is going on. For minimization, you need it greater than 0. Okay. So this part is it. So this is not that simple. This quantity is not that simple. If it is if your function is a second derivative, if it is greater than 0, it is minima. If it is less than 0, it is maximum. Yes. So same thing I am doing, but for partial derivative, it is bit different expression. Because E is a function of two variables. It's not one variable. Now we have the expression for E W0 W1. Now we will solve for each of these and find what is the W0 and W1 from these two equations. That is our job. Can you put dou E by dou W0 equals to 0 and see what you are getting? Right? Then we say that at that particular point, E is minimum. All right. So now our first step will be put dou E by dou W not equal to 0 and get a condition. You know E, right? You know the expression of E W not W1. This is that expression here. Now you can differentiate with respect to W naught and get a condition. So I want you to do that. Written what is the value of E, right? So that if I go to next page, you can refer to it. Okay. You have written the expression of E W naught W1. So I'm going to next page. So what we should compute first? In the have square terms. Are you having square terms? Now, if I differentiate with respect to W naught, it is like differentiating x square. So it will be 2 times of x. Yes, if you are differentiating and again differentiating that one. Yes, that's what we are doing the differentiation. So I'm writing it down now. So now when I do dou E by dou W, no, you won't see any square terms. You will see only linear terms. Okay. Setting up the stage before writing the whole expression down. I could have written, but I'm making you think. So can anyone tell me what's the expression? Follow with me. It will be 2 expression. So you can take it outside as a common. 1 by n is already with you. Are you getting something like this? Corresponding to y2, there will be x2. Similarly, we have n data points. So yn minus w1 xl. So how I will write it in a compact way? We know this thing is there, but how can we? But how you can see y1 plus y2 plus yn divided by n is there. So it is like, follow with me that you can write this in a very simple way. Wi minus y w naught. Yes. Now how it is? Now you can take the summation inside each expressions. How it will be? Summation of yi minus of times. So you will get outside of summation and w naught. And what are you doing? Minus w1 is constant for you. W1 changing. No, w1 is a constant. So you can take it outside of the summation sign. Inside what you will get? Xi. Is it correct? Or did I do some mistake? I is summation mistake. Huh. So this is outside summation. Summation of, now what I do, take this summation to each of the terms. When you do this summation of w naught, n times you are adding minus n w naught to this w1 is constant, take it outside, and the summation of xi. Okay. How to come? Summation of yi by n. What is that? Average of y. That n and n w naught will cancel out. Summation of xi by n is like x bar. That's the average. Yes. So what you will get for the final expression? Eyeball this, eyeball this, that you will get something like this. What is x bar? The mean. Okay with everyone? So we will set this to 0. We will set this to 0. Now you see how you know x bar and y. Set of data points. So you know x bar and you know y bar. But you don't know w naught w1. It is giving you an equation in terms of w naught w1. Yes. So 0. Right. Here. Now next. Huh? How to extending. I could have taken them. Yes. What we should do? Dou E by dou W1 equals to 0. What you will get here? Anyone? Clear, right? This thing is clear. How many? Okay. So dou E by dou W1 equals to 0. Can you check the expression now? Now if you check, just don't need to go back to the expression of error E W naught W1 in your notebook back. Just check now. So I am now applying. You have square terms and you are taking a partial derivative. So 2 is coming on the front and you are taking the derivative with respect to the inner quantity. But you will be differentiating W1. But W1 is being multiplied by X1. Check. Wi is multiplied by Xi. So Xi will be coming in front of your multiplication. Yes, which was not the case previously because W0 was alone. W1 was single one. Now Wi is being paired with Xi. Yes. So therefore you will see some squared expressions here. Whenever I'm saying this quantity, you should be looking at your notebook and thinking about it. So without even solving the expression, I am giving you an idea how the expression will look like. Okay. So sometimes it's also about imagination. Sometimes it's not just solving. So you're with me. Shall we start with this? Minus 2 over n. Just follow with me what you will get. Now you will get x1, as I told you. And again, the same old stuff what you got for the w naught. So it will be the same. Y1 minus w naught minus w1 x1 plus x2, y2 minus w naught minus w1 x2 plus so on, xn, yn minus y1 w1 xn. Is it? Yes. Clear with you. Now we have to go to next page. So can I write in a compact form? So after writing a huge line of set of equations, our next thing is to compact them, compactify them. Okay. Now, can you write in a compact form what you have written now, just before? Is it okay if I write WE by W1 as following the last expression using the summation line sign like this? I equals to 1 to n. Xi will be there. Yi minus W0 minus W1 xl. Till now. Now I want to further simplify this till I get a minimal expression. That's the idea. That's the idea. We want to get a very minimal expression starting from very basics. How can I do this? We will take the summation side in the expression. So how it is minus 2 by n, you will summation of xi yi minus n w naught. N is w naught added. The whole w1 is a constant. Take it outside of the summation, and you get summation of xi. Good, good. Good. So this is what I want. If I write something by mistake, you should help me out. What it should be, now we can't do that n w naught. Now w naught is being multiplied by xi. So it will be summation of xi. Now it is correct. Summation of xi, obviously it is like I equals to 1 to n and I'm not writing again and again. Okay. So can you tell me, like again we will get a simplified expression. So I can write in this way. I don't want this minus sign here, which is a bit tricky. Like I can take it inside and absorb them. So correct me if I'm wrong. Like it will be W x bar where it's a mean W1 x square bar. Because there is a summation square, then I'm dividing by n. You're taking the sum of squares, then taking the average. Okay till now? Positive sign. Multiplied by minus. W1 x square. You will have minus xy bar. Okay. So now we have two equations. Now you have two equations. Now you have two points. Can you W0 and W1? Okay. Now can you give me W0 and W1? That's the idea. That's the aim of solving this set of math. Can you give me? So what we do by do not we got equal to 0. For that we need this quantity w1 x bar minus y bar. Am I right? We got this already. Dou e by dou 1 equals to 0. We will set what we got just now. 2 times of w0 x bar w1 x square bar. See the difference. Minus xy bar. Okay. Now from can you give me what is w0 and w1? That will determine the fit. This will be the best fit because it will give you the minimized error as compared to any other w0 w1. So you can see this fit is unique. This fit is unique. That means this is out of many other fits, many other linear fits. You get one of the fit for your data set for which error is minimum. Okay. W1. I'm very sure that you can easily get from the first equation only, from this equation only, can you see that W0 is y bar minus s? Then only you need to find what is W1 from the second equation. So put this expression there and solve for W1. What is W1? Very nice expression. Aditya and Suresh. Aditya and Suresh. Oh, you sent something today. Today. What's your name? Aditya AK. So Miss Aditya AK will be available in the study group also. So anyone having any issues with this, contact her. Okay. This is how someone is able to do, then you learn from her. That's how exchange of knowledge is there. So what she wrote is correct. So you'll get something like this. And I was very careful while giving the talk here. And I think let's go to next page. Okay. So you know W0, right? What is W0? Y bar minus X bar W1. And W1 will be XY bar minus X bar Y bar divided by X square bar minus. Very careful with these quantities. All right. Very careful with these quantities because xy quantity is not the same as this quantity. Maybe in special cases, but not always. Be careful. Mr. Dikhil Sabu was saying that they are the same and they cancel out. So be careful that these quantities are not same. Maybe in special cases they can be same, but not every situation. Be very careful. I think you can only make an appreciation while we solve a problem. Okay. So again, what we got? So what's your outcome? Given a set of data points distributed somewhat like this, what we did, we found a fit. Okay. We found the best fit. What is this line? This line is y hat given by W naught plus is already being given to you, the data. W naught and W1 we found out just now. So you can have, and this fit line is the best line because it is minimizing errors. Okay. So such regression analysis involving such linear relations between one dependent, that is y, and one independent, that is x variable, is known as simple linear regression. Okay. We can estimate y hat star. Okay. So if someone gives you x star and asks you what is predict the value of y, what you will do? Take the value of y hat star. Okay. That will be the predicted value, where y hat is this guy. Right? Now, actually, there is even a more nicer form than this form of W naught and W. There is a nice form, then nice alternative form to W naught and W. Okay, you can use this form, no worries. But there is a alternative nice form to it. That's we will be deriving now. Yeah. So this we will use while using formulas or fitting a line by hand. All this. Okay. Have you written in your notes what is W naught and W1, the expressions? So if I go to next page, you can always visualize it. Okay. Let us see W1. Let me target W1 for first. Can I write W1, whatever we have got, as the following? Check it again. I am again going to one step backwards, like what we have written. Check it very carefully if it matches with the expression which I had written before. Check it. XY whole bar. That is like summation of xi yi divided by n. Are clear? Okay with this? Minus x bar y bar. X bar is a mean. Y bar is a mean. Those will be constant quantities. Okay. The data sets xi, yi is being given to you. So therefore, x bar and y bar are constants. Okay. So therefore, I only open y bar as summation of yi by n. I don't open x bar. I choose not to. I can put it like this, right? I can open it. I cannot open it. It's my choice. I can take it outside also. I can take it outside also. Okay. If y I can take it outside, x bar is constant. It's a mean. It doesn't change with the variation of W or W. Xi, yi data are fixed. So mean is fixed. So it's a constant. Therefore, I can do this thing. Now, x square bar. What does it mean? X square bar means I am summing the x square data again and again, and I'm taking dividing by n. That's a mean. X bar square. What does it mean? I'm keeping it the same. Till now, everything is clear. Okay. Okay. Just to make your mind clear, whatever step I'm writing, because I will be doing like +3, -3. Okay. End up into a nice expression. Okay. Those are the Those are the tricks. So after this step, is it correct? Is it correct? Okay. Can you visualize what is happening? I will explain again. You see, 1 by n is here. Okay. 1 by n is here. Multiply it here also. So that 1 by n can be cancelled out, right? So therefore, you are seeing n times x bar square here. Okay. And your group together. And what till now? Okay. Till now it is okay. Now, right, if I write the same quantity as follows. This is the trick part. This is the trick part. It is actually equal. And that's the, so how, so who understood this? So everything you can eyeball, but this part requires a bit of more calculation. Our goal now is to show that this quantity here, the top quantity is open, numerator is open. Denominator, how this quantity is equal to this quantity. Okay. Can you note it down? Can you note it down? I have to go. Okay. Okay. Shall I go? Check your notes again. What I meant is xi minus x bar squared will be equal to that. And I will simplify now and show you that it is actually coming that quantity. That quantity will actually come. So how should we proceed? Can we open this like a plus b whole square? What we will get? You will get summation of xi squared plus summation of x bar squared minus 2 times xi x bar. Okay. What I should do now? Can I write like this is equal to, okay, I don't want to. X bar is constant. You are taking summating over n times. So it is n times x bar square. Okay. Minus, since Mr. Albin Borun told we should take x bar outside, we will take x bar outside. So 2 x bar, x bar is constant. What you will get? Anything you are able to see now? What I can write here? Summation of xi squared plus n x bar whole square minus 2 times of x bar. This is n x bar, right? Okay. Now can you see what is going on? What will be here? It will be summation of xi squared plus n x bar whole one n x bar whole square minus 2n x bar whole square. So summation xi square plus, yes, in fact, right? Because plus n x square minus 2n x square. So it is n x bar square. Can you now see this expression? This expression, see this expression. I proved that this expression is equal to this expression. Can we go one page back? Can we go one page back? Can you see now what I have done? I proved just now that these two quantities are equal here. And that's what you are seeing it here. That's the reason why I wrote from here to here directly. Are you able to understand? Hmm? Any issues? Who explain again? So I wrote this quantity as this, but how can I write this? Then I showed that it is indeed true through this mechanism. So we can write now I am coming to a nice formula. So can you, if you remember, this is a special quantity. This is a special quantity. So this quantity we tell it as Sxy. Okay. This below quantity we say it to be X. Okay. Got it? Yeah. Just notation. Just the notation. So previously we formula, instead of that formula, we can use this formula for W1. W1 is Sxy by Sxx. Okay. Where Sxy is this quantity, Xy, this is Sxx. All clear? I like the quantity Sxx. That is, it is summation of xi minus x bar whole square. Very simple expression. No need to worry. But somehow I don't like the expression of xi minus x bar into yi. It could have been more better, I feel. So there is a simplified version for that formula also. So that we will see now. So can you tell me what is Sxy? What I just wrote? Summation of minus x bar into x bar. Yi. Yi is it? Now, can you tell me, we can write in another form. Can you think how we can write in another form? Think that I will give you another opportunity. Like just it is like plus minus, same thing. Okay. So is it write this? Correct? Maybe I should give this to think. Yes. Maybe it might not be correct. Okay. But I'm giving you a hint that you can proceed in some kind of this way. Okay. To get your job is to take this and bring it down to this formula. Have a thought that these are like similar. Okay. So here it was not, at a first glance, it was not clear that this quantity is equal to this quantity. Then we did some algebra and it got clear. So can you make sure that Sxy, you can actually bring it to this form? Hmm? So the whole idea now is like what we are actually doing. What we are actually doing, we already got our formula for W0 and W1. We are done. But I am saying that we can do even better. Find some alternative forms for W0 and W1. How we can find? Through these expressions. W1 is Sxy by Sxx. Okay, which is a bit similar to this one. Now we are only doing an alternative form, nothing else. Already got W0 and W1. You can also use these formulas if you like. Okay, but computationally and manually, these formulas are quite efficient, which I am going to write as a summary. Okay, okay, as a summary, what we have done so far, we found that Sxy by Sxx. Okay, this is an alternative form. W0 did not change. W0 is the same as before. W0 is y bar minus x bar into W1. So while solving the problems, you only need to know these equations, nothing else. Okay. Sxx is sigma of xi minus x bar whole square. What is Sxy? Xy summation of xi minus x times yi minus y bar. Okay. Then from these equations. Now what you will do with this estimation function y cap, that is W0 plus W1x, and this is our all in nutshell. So if I have, so suppose if I am giving you data set x and y, xi, yi corresponding, then you can find the mean x bar, you can find the mean of y bar, you can find sum them up, that is Sxx. Sxy also you can find, those you can do tables. Okay. So W1 you can find, W0 you can find, finish. So you have the coefficients, you can find the straight line. And that's the best fit because you got this expression by setting some minimization condition. So it won't be any other estimation, it will be an estimation where your errors are minimum. Okay. Cool. So now we can verify the second derivative, but later I will show you. First, shall I show you the programming or we'll solve the problem? What you want? Shall we discuss a problem or shall we discuss a problem or like we can implement this in coding? Problem, is it? Okay. All this idea. Okay. Okay, suppose like this is a data set we are getting from a chemical industry, suppose. Okay, what is it? Suppose you have a camphor, okay? Your camphor, you know, it gets evaporated, right? So you can't keep it like that. Okay, can't keep it like that, like open space. They have to make so many arrangements that it evaporates in a very tiny amount of way each day. It can't evaporate like half of in a day. Okay. So therefore, we have what they will do, how they will predict. Today, I kept this gram of camphor and at 5 p.m., what is the weight of the camphor? Today, tomorrow, data set, third day, data set. So collected data set. So this is the data set they have got. So mass and time, okay? Mass and time. Obviously, mass is changing with respect to time, right? So the question is follows. You have two data sets. So time is there in seconds and mass is there, all right? Say these are like 5. When time is 5, the mass is 40 grams. When it is 7 seconds, the mass is, okay, 120. It's just some data set. Don't need to worry if it makes anything like sensible things. There's something which absorbs water. So the weight is increasing with time. what can be a good example? Can you suggest? Salt. Salt. Keep the salt in a jar, open jar, and leave it for 3 days. Then you take the spoon and see the salt content, it will be watery. That means if water is there, the weight has increased. Yes. So this is the distribution of that. At 5 seconds, your mass is say 40. It is an extraordinary salt. Okay. 180. At 16, it is. So, yeah. So can you find the equation of the regression line? So how this actually varies. Now, if you consider weight on one axis, mass on one axis, time on another axis, and plot this set of points, you will have some discrete set of data points. Now I am asking, can you do a best fit? Find the regression line for this so that you can predict, okay, how much weight it will be. Of the regression line. Equation of the regression line means equation of the regression line means y cap equals to w naught plus w1x, and you have to find only w naught and w1 to find the regression. Can you find it? It's easier because you have a lot of data sets and lot of computation, so there has to be a way how to start. So I can give you a tip, like maybe what you can do, list your xi, yi, xi minus x bar, right, in your equation. Then what you need? You need yi minus y bar, okay? Then the multiplication of these two, xi minus x bar, yi minus y bar. There is one more quantity you need. What is that? Xi minus x bar squared. Now, can you tabulate each of the things and corresponding to each of them, like each of the quantities corresponding to xi, y, and fill this table up. Find all the data from this will W1. You do it by hand, and a similar problem we will see using Python. Okay, people. So check yourself, check the calculations, and Albin is also right that you will get W naught to be 11.506. W1 you will get to be 12.208. So the best fit for this line y cap equals to 11.506 plus 12.208x. Okay. What I suggest you is I will show you a Python code for a similar kind of data. Maybe what you can do is plot this in Python. Plot the set of data points you see in Python. Those will be set of data points. Plot this line Python. It will be a straight line. Okay. So see if it is the best fit or not. Okay. So this is an assignment. So this is assignment 1. Okay, so hmm, hmm. similar set of data in Python. So again, I am defining everything in my main function. You can just write it like that. Up to you. I am defining X and Y array as follows. So as you can see, I have written a set of numbers for them. Check. I think are those data sets equal? This will be your job. Check that these data sizes are equal. Maybe one is looking longer than another. 7, 8. So those two decimal places are occupying more space than as compared to the other one. So otherwise, it's the same data size. Okay. As I told you in the class, I wrote it here. X dot size. So you can use length function also, len, to find the length of the X. So I use X dot size. What is the size of X? Array X. Okay. You can use len also. X bar, now you check the formulas. X bar, what I am doing, I am finding the mean. What I do, dot sum X by N. X bar. Okay. Y bar also calculate NP dot sum Y by N. X bar I have, Y bar I have. What I need to calculate again? X bar. Okay. How I do it? NP dot X comma Y. So each element, I am doing it pairwise multiplication. First element of Y plus second element of X multiplied with second element of Y plus like that. Okay. X square bar. First you square, then you take the sum of them, then you take the mean. Okay. Okay so far. So why I am doing all this? Because these quantities are there in the expressions of W0 and W1. So now I am calculating this W0 and W1. I think this is the first expression. This is the first expression. Which expression? First expression we calculated, and then I told you we will calculate an alternative form. So till now, in the lecture series today, for the W0, W1. One is the simplest form, another is an alternative. This is the first form. It is not Sxy by Sxx. It is the first form. You can try, you should try the second form, the second assignment. Okay. First assignment, you know, whatever you did by hand, you have to show in Python. Second, this expression I did using the first definition. You have to confirm that you are getting the same result. All right. Two assignment, two coding assignments. Next class. So what I am doing here is the same. Check your formulas again for W1 and W0. That's what I have written it here. XY bar minus X bar into Y bar multiplied by Y bar divided X square bar. Okay. Can you check your notebook and say that it is ended correct or there are some errors? Check the formula again and let me know if it is correct. I might have done wrong. Yeah. Okay. Okay. So I calculated W0 and W1 based on my set of data, right? Then Y hat is W0 plus W1. Finished. Okay. While coding, okay, if I use X, what is X? It is the set of discrete data points, right? It is a set of discrete data points. Then it won't be a line. It will be another set of points. Okay. So therefore, I did something else. I found X, you see this array X, right? Array X. Can you eyeball and say me the minimum value of X and the maximum value of X? Minimum is 2. Minimum is somewhere more than 2, 2.5. Maximum is around 5. So what I did, I did 2 to 24 and I linspace 1000 points. Okay. Then I'll get a straight line fit. You understood? We have the expression of the straight line. but we can't use this set of data set to plot the straight line. Why? Join those lines also. Okay, but I just divided the min and max of x and I just joined it by a straight line. Okay. Now I'm plotting x1 versus w0 plus w1 of x1. The straight line I'm plotting. I'm plotting two things. I'm plotting xy, the real data set being given to us, the scattered points you will see, and I'm plotting the best fit. That is the least square regression line. Okay, that is w0 plus w1x in orange color. Okay. Now in the below plot I have run. Okay, till now. If I don't do the main, if I don't show this main function, I only come. You have to call the main function because all these things are defined in the main function. So I have to, if you don't write main, you are not calling the main function, you will get no output. The program will run, no output will come. So you have to write main so that you are calling this function so that all these things will be printed and plotted. Okay. So far, I plotted these data lines, data points. It is like this. Yeah. Negative sign here, the slope is negative. The slope of the line is negative because one of your coefficient is negative. Okay, you can find the slope of the regression line also, how it looks. Based on the regression line coefficient, you can guess how your regression fit line will actually look. Whether it will be like this or like this or like this. Clear? So this is these are the data which I had already given to you in the beginning of the code. And this is what you have shown best fit. Okay, so far. So we saw how to compute W0 and W1 both. And also we showed through a coding perspective. Now your job would be to, like, you can give the labels. I have not given the labels. Yes. So you can create the labels. Okay. According to your need. So this next problem we can only see after we learn another concept. Till that point, I am restricting it. Okay. Some new concept you have to learn. Till that, let it be undisclosed. Okay. Okay. So, if second minimization condition, if I the second minimization condition, what we have to do? See, what is that? Check your note that it was this quantity. I summation of this minus W1 of xi. Here. So far. What is doing by dou W0? Dou minus 2 over n summation of xi times yi minus W0 minus W1 of. Now what we want to solve? We want to find what is dou to. Everyone saw that complex equation greater than 0 that we are solving. So each component we have to find. So is it quantity, right? What is this quantity? Can anyone say? You have to differentiate this again with respect to W0. That's so nothing else. Every quantity differentiating with respect to this one. Again, it will be how much? Tell me. Huh? So it will be minus 2 over n summation of minus 1. Right. So it will be minus n. So it will be 2. It is greater than 0. This one here summating for n times. So it will be minus 2n and n cancels out. What is dou 2e? I1 xi is already here. I moved inside. Xi will be there. So xi squared. Yes, of course, this quantity is positive. Why? X square is always positive quantity. Squared quantity is minus minus multiplied positive. N is always positive. This quantity is always positive. Clear? Why I am not doing this? Due to that expression, the complicated expression. What else do we have to find? Can you tell what next remains? Quantity, right? Can you say what is this quantity? Do this. Try to find that this will be 2x bar. I did those two quantities, so now you should do this one. What? So now can we put the pieces back together? The big equation. We are ready. We have all the quantities right with us. What are those quantities? So what is our expression? Our expression was do then this one. Then where? Yes. Are you sure? Where? I bet I missed the square term. That square term. Got it. Hmm? So now we can come back, is it? So can you tell me what is this quantity now? Based on all of the quantities here, what we have got, can you come to a conclusion? Can you come to a conclusion that this quantity is this? This will be like 4 by n summation xi minus x bar whole square. And this will be always greater than 0. Come to a conclusion that after solving this, you will come to here. I already have it here. You just have to plug it in. So, which you have to work it out to land it to there. From here to here, how we'll get? So this one to show that it is actually greater than zero. This quantity, this complex quantity is actually greater than zero is your task. Simple, right? You have all the quantities. You just have to see, and you'll finally. I also showed you this. You will get to a squared equation. Something squared quantity you will get, and squared quantities are always positive. For that choice of W0, W1 which you found is min, and we got only one choice of W0, W1, right? Did choices of W0, W1? No. We got only one choice of W0 and W1. That means the solution is unique and it is a minimal solution. Okay, the root is minimum. And such form of equations are known as convex functions, where you get only observe like a parabola kind of. There is only a one minimum. Yes, so something like that. Visualize that error function was having all terms. Error function was having sum of square terms. So it is like the shape will be like a parabola kind of. So it will be like some, yeah, it will be something like this, and error sits here. That is the minimal error. All these are errors. You have a choice which one to take. Which one you will take? This one. That's the minimum. Okay. So the function E W0 W1, which is the error function, okay, has only one stationary point, the root value, which we solved. And it is actually minima. Okay. And that E function is a convex function. Okay. Don't need to worry. Like I'm saying just from observation. Yeah, such a property of in EW0 W1 justifies your cost function and any other things. So if you are having an error function, it should be a convex function and it should have one stationary point. That's like a minima. Okay. It can't have multiple. So this is the minima for you. How to get this curve? How, just a sketch. Just a sketch. You don't need to worry that I need to see, I need to plot. No. Error has squared terms. So therefore it must be behaving like a parabola. And how a parabola looks? Parabola looks like this. For a parabola, you have a minimal point like this. Think it's the intuitive thing. Got it, is it? That's where we got two equations. We solved simultaneous equation. We got formula for W0, W1. Then what we did? Then we solved a problem by hand, and then we solved using Python. Like using Python, we saw the regression line clear. But we forgot to check the actual minimization condition, that the second order partial derivative. So we did it here. And it is actually coming to be greater than zero. So our W0 and W1, what we have got is correct. And it actually gives us the minimum error. Story so far. Okay. It's okay, right? Now, some things you will see pretty common, like why regression is behaving like a machine learning algorithm and all. For that, these things you will be very quite often see during your ML or something like, see, when I tell you about this, you just think in your mind, I'll draw a sketch. So simple regression for a training data set. We already have a training data set, T. I don't have to say it again and again, T, which is like xi comma yi, and I is going from 1 to n. So this T is your training data set. And regression already know, you know, it's a supervised ML algorithm. Okay. looks like a flow chart. I just want to, what I'm drawing is actually making sense. Makes sense. Does it make sense? What I actually drew, it's a flowchart of what we need. That's it. So what we need, can anyone understand this plot, this sketch? So you have two inputs, one x. You already know x. Is it correct? W0, W1. Then you are feeding them here. Okay. How it is? If one will be multiplied with W1, W0, x multiplied with W1. What it is? Here W0 will go, here W1 x will go. Then what you are doing it here, sigma means sum. You are summing it up. So here what you are getting? So that is what? This is the y hat. What is that? It is the output. But it also has another name. What is that? Estimation function. So it's the estimation. So these kind of graphs you will more probably see in various. Okay. In neural networks, you have seen many circles are there in different layers. Our input layer, output layer, lot of cross connection. Just a simple version of this. That is a more advanced version. A very simplified version is this. Okay. After this is completed, we will see regression in terms of machine learning. So how neural network, how many hidden layers, how many input and output layers are done. At least these terms won't be new to you when you will be learning a machine learning. Okay. Those terms might not be new. Okay. Yes. So we have two more important concepts. Okay. Two more important concepts. And these two will be very simple, very nicely. So keep your attention very close. Okay. One will be like, these will be very intuitive, uh, important stuff. Okay. But whatever you have seen, that was the hardest part. Okay. All are done. Now the important stuff is coming. Okay. Two. And these things you already know. These things you already know in the last class of data analytics. Last class of data analytics, I gave a very speedy overview of calculating SSR, SST, R2, R, okay, quantities. Through a different lens, okay. So how? So how you will quantify a good fit? How you will quantify a good fit? We will calculate an error and we will minimize the error and we will get, okay. Okay, so how to quantify? Shall we shift? Like how we will quantify? How we will quantify how good a fit is? So something is there like known as residual. It's the same as error. but yeah, it's a different name. If you're computing for each data point, that is known as residual. What is a residual? It's the same. We will say denoted by EI, data point. For each data point, we are calculating the residual. What is the residual then? Can anyone say? It will be the data point given to you, yi. Yi is known to you, minus your predicted data point. How you do the prediction? You fit a line, right? You fit a line. So that means you know the yi at that value predicted. So what we are doing, given minus we predicting. Okay. So that always note y hat means I am fitting the line. That's the line equation I am fitting. Okay, this is the notation. Some might get confused. Let us see the residual concept EI, that is yi minus yi hat. Okay, yi is the data set already given to you. Data set okay, yi hat is the predicted here. Okay, so how I should write it? Yi minus what is, we have a formula. So minus w naught minus w1 xi. All clear. Can I write in another way? yi minus y bar minus x bar w1 minus w1 xi. Can you think if it is okay? Okay. I just expanded the formula we have for w naught. Yes, I just expanded w naught. That's it. So now I can group them together. Yi minus y bar minus minus xi minus x bar. Is it correct? Correct. Xi minus x bar plus. Okay. Okay now. Okay now. Hmm? Minus y bar plus x bar w1. Okay. Oh, then okay. Oh, it's okay. And minus xi w1 and minus xi w1 we have. What I want you to do is compute the sum of all these residuals I equals to 1 to n. What you will get? Summation of yi minus y bar, is it correct? Minus w1 is a constant, you can take it outside. Summation xi minus x bar, I equals to 1 to n, I equals to 1 to n. Okay. Always 0. Is it 0? That you have to think. I have given you a lot of tricks above. We have done a lot of tricks here. We have done a lot of tricks. Some kind of trick you have to apply and understand. When you do the summation of errors, it is coming to be 0. Check. since summation of all this error or residuals is 0, is not a good quantity to quantify your error terms. There would be, when you consider only error EI, there will be some positive error, there will be some negative error, and such a way that this will come to 0. So therefore, negative error and positive error you are just ignoring. What you should have taken? Summation of EI squared. Error square, it is meaningful, not the error. That's the motivation why I am showing you this. So summation of EI, check. Assignment. Next please. So the next class, there are 2 coding assignment, 1 theory assignment. This small piece of paper also you write. Why you get 0. So summation of EI, this quantity is not a good estimate. Not a good estimate. Why? Because whatever you do, it is giving that error is coming to be 0. But actually there are hidden errors. There is plus, there is some minor error which is getting cancelled. So therefore you should do something more. This is not a good one. Not a good one. Okay. So this is not a good estimate for your error calculation. Summation of error is not a good estimate for error calculation. Best way you can go is maybe you can do summation of EI squared. That positive, and this will always be greater than 0. That's the motivation. Assignment for so now we will be looking at some of the quantities just to form a formula. Okay, not following through any single step. I'm just writing some stuff. Then you can see that I'm actually forming a formula. It is all about SSR, SST, which you have learned in data analytics. Can you like, okay, let's look at the square. Okay? What we are doing. What I told you here is summation of EI is not a good quantity. We should look at the square. For that, maybe I will start with this quantity, yi minus y bar. I'm not starting with somewhere you know. Just it's a random start. Then I will show you that all falling in place. Yi minus y bar. Now, can I write it as this? Write it as this. Can I? I am just adding and subtracting yi cap. Anything new? Is it? I told you we need a square quantity. Okay. So when you consider the error square, this quantity will not come. Will this quantity come? No. You will get something like yi minus y bar squared. Can you compute this quantity? That's the idea. Can you compute this quantity? What will be this quantity? This will be this one squared, right? So it is a plus b squared. Just a plus b whole squared. Can you tell me? It will be just this upper guy squared. Can you tell me this quantity? Is it correct? Yi minus y bar squared plus yi minus yi cap squared plus 2 times yi cap minus y bar yi minus yi cap. Okay, so far. Everything is okay, but we are worried about one term. This is the cross term. This is a very nice quantity. This is a very nice quantity. This might give us some trouble because it's a cross term. Multiplication of 2 quantities. Okay. So maybe we can simplify it further. right? So here all the things are hidden. So we have to simplify this quantity. So this is usually known as the cross term. This is the cross term because two different terms are getting multiplied, two different, so it's a cross, we are saying cross term, cross multiplication can. So this term can you simplify? That's the question. yi cap, sorry, minus y bar into yi minus yi bar. Can you simplify? You should tell me that I am doing something wrong. Can I simplify this? Can using, you know how W0 and W1 looks. You know how W0 and W1 looks. Can you see them and then say how we shall write it? Yeah, how we should write next. Some terms you should actually think like how they are coming because some new things we have to do in order to, but some old stuff we are going to use it in the middle. Shall we do this thing? Maybe someone next class can come and explain on the board after I give you the set of notes. It's explained in the notes. Okay, sounds good. Yes, because these quantities you have to understand yourself. Every step, these are very small, small steps. So maximum like you will be using the W1. What is written in terms of X bar, Y bar, Xi, Yi, all those things. Okay. So anyway, after you do some calculations, which is your assignment for next class, they will come to the board and write. Okay. I'll ask randomly. Random number we will generate. That serial number randomly will. Okay. So why we are doing so much of different things now? It's very like we have. It seems like we have deviated from our path, right? But all these things were done to arrive at a formula which I will write directly here. But next class, one of you will come to the board and write. Okay. Follow me. Like there are some steps. Okay. A3 class. There are two coding assignment, one small assignment for the text, and this is the main. You come to the board and write. Okay. Write in black. Follow me this one. Formula. Okay. And it has this formula has some meaning to it. So it is like many huge things are stored in this formula. So it's an important one. Summation, every time summation I equal to 1 to n yi minus yi cap square. Okay. Now this quantity is important because this quantity which you see termed as SST. Okay. This quantity which you are seeing is referred to as SSR. This quantity is SSRES. What are these quantities? What are the meaning? So SSR is known as sum of squares, and it is like from a regression concept, like square of sum of square regression. Okay. What is sum of square total? Why? Shall we move to next page? Let me erase this. Anyway, I will write it fresh. I think below the notebook, it is creating some error for me, like jumping here over there. So SS sum of square, regression, SST. So sum of square, it is total, okay? So, like last class, SSRS, SST, SSR. SSRES means sum of squares residual. Okay, squares, but it is of the residuals. All right. So this just a simple equation. C equals to A plus B, just like that. It shows you, it gives you a relation between sum of square total, sum of square residual, and sum of square. Yes, three quantities. Okay. That's not it. After we have this, we can actually see and define something else. Actually helps us to define R2. This actually helps R2. What is R2 we learned in data analytics class? Can anyone remember? Chain of determination. How many of you remember? R2. We solved R2. R2 we know, but what is R? R2 is like coefficient of determination, but what is R? Okay. So for now we know that we have this relation SST, the sum of square total is made up of R plus SS res. Yes, sum of square total is sum of the residual plus sum of the regression. So this helps us to define R2. These quantities, they help us to define R2. That is the coefficient of determination. Coefficient of determination. And how it is defined, do you remember? Check according to this one. So different books, they use different formulas and different notations. So maybe like you can see R2 here will be like the division of SSR, the regression over the total. Yes. And how it is, can you write in some other term? You can write through this summation term. As due to this equality, you can write it as SS residual by SST. Is it okay? You can just write SSR as SST minus SS res and divide by SST. Then you get this quantity. So you can see, given the set of data points, how you can calculate R2. If you want to calculate R2, you can compute these steps, SSR and SST, where SSR and everything is in your hands. Every data set you have. YI you have, Y bar you have, YI cap you have, everything you have. So now you know how to define R2, is it? Always check that R2 has a special property that R2 will always lie in between. What does it mean if R2 is close to 0? It's a bad fit. What does it mean if R2 is close to 1? It's a good fit. But R2 should be close to 1. It should not be like equal to 1. If it is equal to 1, it's a sign of overfit. Overfitting. Okay. So it should be like 0.8995. Okay. But if you see 1.01 or 1, it is overfitting. You should not encounter overfitting. So actually, like, I asked you the question, like R2, you know, R2 is a coefficient of, but what is R? What is R? So we discussed that you will show next class to us that SST equals to sum of square total equals to sum of square regression plus sum of square residual. Yes, we got this quantity. Then we defined R2 to be SSR by SST. Okay, SSR, SST, SSRS, all these things you can calculate. R2 we know that they will lie in between 0 and 1. If it is, it's a bad fit. If it is towards 1, it's a good fit. If it is equal to 1, not good. It implies overfitting. Okay. Now, in order to make sense of the quantity R, we have to write R2 in terms of SXY, SSX, all these quantities. So this is the only place where you have to put your brains into use. Put your brains into use to see that you can write these two things. Put your brains into it. You can do it. I know. Only you have to use definition of W not W, nothing else. You use definition of W not W. After you get R2 as this expression, you can find R. Take the square root. So R in between -1 and 1. R, I disclose that it is the coefficient of correlation coefficient, right? It is this formula. How many of you have seen this kind of formula for correlation coefficient? Seen for correlation coefficient. You might have seen as rho, sigma. So those who are facing, I strongly recommend that you meet with our club, numerical methods club people, and read this slide in particular. Read this slide in particular. This slide has a lot of information than actually it seems to be. Now, discuss how it is. You can see from your faces that these equations are so troubling for you, but just believe that it is not that difficult. Only 3 people. I should add more people into the group. People. So you should meet with them and discuss, especially this slide. This is important. Makes sense to you, like do your calculation yourself and get to this point that you should be able to appreciate once you understood. Don't let it go like that. Then only it will be okay. So just nothing new. I will start now. I think already time it is. Oh, shall I just cover the implication? Then we'll stop. Just the will be discontinued. What is just a small one. So you know what is the implication of R? You already know it. That means regression line is close to your data points. Okay. You should have said to me, it's already 12. I don't have any time to see. R2 is close to 0. What does it mean? Regression line fails to capture the actual data points. Make sense? R is greater than 0. What does it mean? Means positive correlation. It's a correlation coefficient, right? R is a correlation coefficient. R greater than 0 means it's a positive correlation. That means if X is increasing, Y will also increase. R less than 0 means negative correlation. Yes. R is approximately equal to 0. There is no correlation. It is okay. So for something like maybe Dikhil Sabu enjoying dal vada and say our Sangamesh eating biscuits doesn't make sense because they are two different quantities that doesn't make correlation. Okay, so they are not correlated, right? So high value of R2 is necessarily good, but If it is very close to 1, might indicate overfitting. Learn today. I think that is it.